Hello students, welcome to my channel. Today I am going to discuss about fundamentals of the analysis of algorithm efficiency. So we all know algorithm. Algorithm is nothing but step-by-step process to solve one particular problem. After creating algorithm, we need to analyze whether it is efficient or not. So that concept is nothing but analysis of algorithm efficiency. Here, efficiency algorithm analysis is nothing but determining the computing time and storage space requirements of an algorithm. So we can say an algorithm is efficient based on the time taking and storage space. Okay, so that is also known as performance analysis or efficiency of algorithm. So by using the analysis of algorithm, we can select the efficient algorithm. For example, if we have one problem, there are many algorithms are available to solve that particular problem. But we have to choose the best algorithm. So the selection of algorithm is possible by analysis of algorithm. So after creating an algorithm, we have to analyze in terms of time complexity as well as space complexity. So based on that, we can select the efficient algorithm. Okay, so here the efficiency of algorithm can be in terms of time as well as space. So the algorithm efficiency can be analyzed by the following ways. So these are the four ways. By using these four ways, we can analyze the algorithm. Analysis framework, asymptotic notation and its properties, mathematical analysis for recursive algorithms and non-recursive algorithms. In this particular video, I'm going to discuss about analysis framework. In the next coming videos, I will discuss all these remaining topics. Okay, so first one is analysis framework. So this is one systematic approach for evaluating the efficiency of an algorithm. So it involves measuring the algorithm performance in terms of time complexity and space complexity. Time complexity is also known as time efficiency. Space complexity is also known as space efficiency. Time efficiency is nothing but the algorithm how, indicates how quickly an algorithm runs. So how much time it is taking. Okay, if the algorithm takes less time to execute, we can say time efficiency. Okay, space efficiency is nothing but refers to the number of units that the algorithm takes in addition to the space needed for input and output. Okay, so if the algorithm takes less space, we can say it is efficient in terms of space. Okay, so algorithm analysis framework consists these four measuring units. Okay, so the first one is measuring an input size, units for measuring running time, order of growth, worst case, best case and average case efficiency. So in analysis framework, algorithm analysis framework, by using these four, we can say whether the algorithm is efficient or not. Okay, so let's see one by one. The first one is measuring an input size. Okay, the input size is denoted by n in most of the algorithms. Okay, for example, if we take searching problem or sorting problem, n indicates the number of array elements. So how many elements the array consists, that indicates n. If we take matrix multiplication problem, n indicates the matrix order. Okay, if we take traveling salesman's problem, n indicates the number of cities he visited. So in this way, n is nothing but input size. It will take input size. Therefore, the input size n is very much important in analyzing the algorithm. So why? So this is the measuring input size. For example, if the array contains 10 elements, n is nothing but 10 number of elements, like that. So the first one is measuring input size. So the second one is units for measuring running time. Okay, we cannot measure the running time by seconds, milliseconds and so on. Why? Because The time is dependent on computer, compiler and the program. So we cannot say this program is taking 10 seconds or 20 seconds. That can be vary in one system to another system. So that's why it is not possible to measure time by seconds, milliseconds and so on. So that's why we would like to have a metric that does not dependent on these extraneous factors. Okay, those factors, those metrics are operation count and step count. So these two are the computing the time efficiency of algorithm. These two are methods, operation count and step count. So first we have to measure the input size, and second we have to measure units for measuring running time. So that can be measured by using operation count or step count. Let's see what is operation count. Operation count is nothing but how many operations are there. Okay, so the time is measured by counting the number of basic operations or key operations. If we take, this is the one example, A is equals to A into B. So this particular step contain 1 unit of time. Okay, so this is one operation, right? For performing this operation, it will take 1 unit of time because only one operation. Let's see the second statement. For I is equals to 0, I less than n, I plus plus. So this is one loop. It will execute until the condition is false. For example, I is 0, n is 5. So it will execute 5 times. Okay, and next, so if it execute 5 times, then this code takes 5 units of time because it executes 5 times. Now, if n value is 10, it will take 10 unit of time and it executes 10 times. So this code takes n units of time because it executes for n times. Okay. So let's see the another scenario. It contains two loops. This is known as a nested loop. The loop which contain inside another loop is known as nested loop. Okay. I is equals to 0, I less than n, I plus plus. Next, if the condition is true, then it goes to one inside another loop. J is equals to 0, j less than n, j plus plus. Next, it will execute the statement. So here it will take n square units of time. Why? Because here n units of time, n units of time, and here also n units of time. So here it will take n square units of time. Why? Because it executes n square times. Okay. Like this, we have to count the operations. Next one is step count. How many number of steps are there? Here, how many number of times one instruction is executed. So if we take this, A is equals to, same example I took, A is equals to A into B, it will take only one instruction. Okay, so the step count is 1. Here it will execute n number of times. So that's why step count is n. Like that, here it will take n square. It will execute n square times. So that's why the step count is n square. Okay, so for measuring units of measuring running time, we have to count the operation count and step count. This is the second one, and the third one is orders of growth. So this order of growth of algorithm is nothing but approximation of time required to run the program as input size increases. For example, I have 5 elements in an array. I want to sort those elements. So for, let us assume it will take 1 minute of time. For sorting 5 elements, it will take 1 minute. If array consists 100 elements, so I'm increasing the input size. If array contains 100 elements, it will take more time, not 1 minute, it will take more than 1 minute, right? So order of growth is nothing but it is used to measure approximation of time required to run a computer program as input size increases. If we increase the input size, how much time it will take. not exactly, approximation time required. Okay, so remember this table, order of growth. So 1 is for constant, log n logarithmic, n for non-linear, n log n is a linear logarithmic, n square is quadratic, n cube is cubic, n power n, 2 power n is exponential. Okay, this table is very important. So the order of growth is, for constant it will take, for constants it will take less amount of time than logarithmic. Okay, for constants it will take less amount of time than logarithmic, and for logarithmic it will take less amount of time than linear. Okay, so this one is a constant, constant is less than logarithmic, logarithmic is less than linear, linear is less than um, linear arithmetic, and linear arithmetic is less than quadratic, quadratic is less than cubic, cubic is less than exponential. Okay, so like this, I hope it is understandable. Okay, to know how various functions grow with n is nothing but number of inputs. It is advised to study the following table. So, n here n is used to represent the number of inputs. For example, the number of inputs are 1. The log n is nothing but, log n is nothing but logarithmic. Okay, logarithmic takes zero amount of time. Okay, if if we increase the input it will take 1, for 2, for 4 it will take 2, for 8 it will take 3 amount of time, for 16 it will take 4 amount of time, for 32 5 amounts of time. Okay, like that. Here n log n is nothing but linear arithmetic. Okay, so if we increase the number of inputs, the time is increased, the required time is increased in every problem. Okay, whether it is constant, logarithmic, linear, logarithmic, quadratic, cubic, exponential. So if we increase the number of inputs, the time required also increase. Okay, it will take more time to execute those programs. So the first one is measuring input size. The second one is units for measuring running time. And the third one is order of growth. And the fourth one is worst case, best case, and average case efficiencies. So the first case is nothing but, the name itself indicates. Consider the scenario where algorithm takes maximum possible time. So it is taking more time to execute, to complete the execution. So it provide upper bound on the time complexity. Okay, so it is taking more time. So then in that case we will say worst case analysis. Okay, for example, for 5 elements, for sorting 5 elements, if it takes 2 minutes or 3 minutes, we can say that is worst case analysis. Why? Because it is taking more time. The next one is best case. This scenario examines the shortest time, small amount of time algorithm takes to complete its execution. While it might seem ideal, it rarely represents real world situations. Same problem, for sorting 5 elements, it will take only 30 seconds. We can say that is, normally computer will execute the programs in nanoseconds. Just we are assuming 30 seconds, 1 minute, like that. Okay, so if it takes 30 seconds, we can say that is the best analysis, best case analysis. Okay, so if the algorithm takes in between best case and worst case, we can say that is average case. Okay, for for example, I am taking, for sorting 5 elements it is taking 2 minutes. For sorting 5 elements it is taking for example, it is taking 3 minutes, and it is taking 1 minute. we can say the average case is 2 minutes. Okay, by considering all possible inputs and their likelihood of occurrences, the average case analysis offers more realistic perspective of an algorithm's performance. Most of the algorithms will be in average case analysis. Okay, by using these, we can define if the algorithm takes more time, that is worst case. If it takes less time, less time, we can say that is the best case analysis. And if it takes average in between best case and worst case, we can say that is average case analysis. Okay, by using these four, we can say whether the algorithm is efficient or not. So that is analysis framework. So in the next class, I will discuss about asymptotic notations and its properties. I hope this is clear. It is clear. If you have any doubts regarding to this video, please comment me in the comment section. For more videos, please do subscribe my channel. Thank you.